It's kind of small, huh? I make that a little bigger. X, it's like that. And they're asking which of those four is the right number line situation for that.
The X is the
Yeah, what does that say in there? Are we good with? Yeah, you good with that? So the symbol has a wide side and it has a narrow side. So whatever's on the wide side is the bigger, whatever's on the narrow side is the smaller thing. Right? You know that, right? So X is greater than or equal. That's the bottom of an equal sign. You know, like an equal sign has two lines, right? That's the bottom one. So greater than or equal, X is greater than or equal to -9. So which of those number lines shows that? Greater, where the shading is the X. So let me ask you first off, could it be A, for example? Well, here's the -9, and where is the X? The X is to the right. Is that greater? Is that what greater is? Yeah, greater's to the right, huh? Greater numbers go to the right. See them, 0, 15, bigger numbers are to the right. So the shading should be to the right of the -9, huh? Because the X is the shading. Whatever you're doing with the shading, you're saying that about X. So that's right. This one's also right. B and C are out. No way and no way. Because the shading is going to the left. So that's not it for sure. The shading has to go to the right because that's what greater means. Greater numbers are to the right. Now, which one is it, A or D? It's D because D has the solid bar, solid dot, I mean. And this is got a hollow dot or not solid. Notice. So the answer is really D. Why is that? Why do we want the solid dot?
to show that equal.
Yeah, because that's what it means. You're greater than or you're equal. So if you're equal, you can be right on the -9 or bigger. But if there's a hollow dot there, that means you cannot include the -9, huh? You can't be right on it. But we want it. We want equal to. If this problem said only greater, let me just change it. If it said like this, just greater, then that would have been A. That would have been the hollow dot there. Is that making sense on that? So basically, if you have a solid bar, you have a solid dot. Solid bar goes with the solid dot. That helps you. Solid bar, right there. Solid dot, right there. Solid goes with solid. Solid bar with solid dot. Questions? Is that good so far? This section looks more promising already. How about number 2? Can you see number 2 okay? Let me make it a little bigger. So 1, like that. So number 2, what about that one? Is it A, B, C, or D on number 2? Is the shading supposed to go to the right or the left?
B. No.
Greater.
A.
Greater's going to go to the right. So it's either B or A.
It's A.
And it's A because A has the hollow dot, which is what we have. Right? We have no, it's not a solid. We have, well, I'm saying that funny. We have no solid bar. We have no solid bar. So then we do not have a solid dot. And it's to the right because greater means to the right. Greater numbers, if I said I'm thinking of greater numbers than 4, that's like 5, 6, 7, 8, huh? Greater than 4. Is that making sense? Everybody see why it's not B? Because that has the solid dot. You good? Questions on that? All right, so let me write this a little bigger. There we go. Okay, so remember, whenever we're saying about the x, we're saying about the shading. So the x is the shading. So what is it saying about the x here?
Greater.
It's between 3 and 6. How about that? Can I just say it that way? It'd be easier. So look at the different shadings. Look at A, for example. Here's the x, here's the x. That's not right. That's not between. Which of those has shading, A, B, C, or D? Which of those has shading between 3 and 6?
B and D.
Both of these two. Now we just have to figure out the dots, huh?
Is B.
Yeah. So everybody okay with that? Does that make sense? So again, one more time, let me say that clearly. The x is saying what's true of the shading. So if the x is between 3 and 6, then we want shading between 3 and 6. So it's one of these two. Now, how do you know which one? Well, the 3 has no solid bar, so no solid dot. The 6 has a solid bar next to it, so solid dot. So it is B on that one. We good? Now, how about number 4? Can you do number 4? Let me make it a little bigger here. Change the color up a little bit. X minus 3 greater than or equal to -9. So first off, you got to solve for x. They want you to get x alone and then figure out which of those 4 graphs is the right one. So can you get x alone first off? That a little bigger there. So what do we do to get x alone there? Add the 3. So that means x, these cancel, greater than or equal to. Now what's -9 plus 3?
Is -6.
-6, we all good with that? Right? You lose $9 and gain back 3, you're down 6. Good. So now, there's x alone. Now we can figure out which of the shadings is right. I'll give you a second. Which of those shadings is correct?
Is that greater than or equal to sign, like an equal sign when we're solving?
Kinda, yeah. Yeah, as far as for solving it is. Totally. Yeah, it's totally like the wall. It's like the equal sign for solving. Yeah, well said. Serahi. Serahi.
There you go.
All right, get a little better. So yeah, that's right. So it's just like an equal sign. So x is alone, greater than or equal to -6. So is the shading going to be to the right of -6 or the left?
To go to the right.
X is greater, white side. So greater things are always to the right, aren't they?
Yeah.
Don't let the negative throw you off. It's going to be to the right of -6. Greater numbers are always to the right. Lesser numbers are always to the left. So it's C. So everybody see that? The X, the shading is to the right of the -6. You can see that tiny print down there. It's to the right. Is that okay? Should I make that bigger? You want to make that bigger? Can we start by just solving? And yeah, like Serai was saying, the greater less than, that's like an equal sign. So just treat that like an equal sign, left side, right side. So go ahead and do the stuff you've already learned how to do at first. Go ahead and get x alone kind of thing. So what do you do when you have x on opposite sides? Yeah, do the x's first, right? Don't worry about the -4 and the -2. Do the x's first. And then once you get it, can you go ahead and shade it on your own? Like just go to a number line and show it. All right, so, okay, so you all know pretty well, I think. We start by subtracting 8x from both sides, is that okay?
Over here, x is still not by itself, right? So I think
So 9x minus 8x is 1x.
2, 8x by itself.
Bring that down. We good to there? So we have x on opposite sides. We get rid of the lower one, don't we? And now x is over here, and what's he always saying? I want to be alone. So how do we get this x alone?
But we remember it has
I'm going to
this left side right here. So we have
add 4 to both of them.
so if
We good there? Right, that'll get rid of that. And bring down the 1x. And 1x, that's just x, huh? I don't need that 1. Greater than 2. Okay, it's good to there. Now, let's just go ahead and do the shading on our own, and it'll be easy to do the multiple choice. So let's just draw a number line, and just go ahead and put 2 right in the middle. It doesn't matter. You might think, well, 0's in the middle, whatever. Doesn't really matter. I'll just put 2 in the middle.
so it's gonna
Okay, now,
go that way.
am I going to shade? Let me let you think about it for just a second. So think if you want to shade to the right. It's either going to be right of 2 or left of 2. Let me give you a second. Look at what that's saying. Think about where x is. What is it saying about x? And that's the shading is the x. So where is the x? The x is greater than 2. Greater than 2. So does that mean the x is on the left of 2 or the right of 2?
On the right.
Right, because greater numbers are to the right, aren't they? Like 3, 4, 5, 6, those are to the right. Lesser numbers, 1, 0, and the negatives are go to the left, huh? So greater means to the right, so the x is to the right. That means the shading is to the right. Because the x is the shading. What you're shading is where x is. Now, do I put an open dot here or a solid dot? Yeah, no solid bar,
Open.
no solid dot, open, huh? So there we go. Yeah, Carlos.
So with that equation, it doesn't matter how many numbers are to the right of it, you just make a solid line?
Yeah, because we're saying everything greater than 2. Yeah, we're saying all the numbers greater than 2.
So you would start at the 2?
But yeah, at the 2, yeah, because it's anything bigger than 2. Like even 2.1, even things, closer than 3, like 2.1. Anything, even like 2.0001, anything just barely bigger than 2. And everything bigger, way bigger. Yeah, that's what greater than 2 means. Be like if I said, hey, I'm thinking of a number and it's bigger than 2, and it can be a decimal. Then I could be thinking of any number bigger than 2, not 2 itself, but anything like 2.01 or 10 million, right? Anything bigger than 2. Good? All right, let me let you do that one. So go ahead and solve for x, just like if it was an equal sign. The set of E has told us that's right. Just like if it was an equal sign, solve for x there. And then go ahead and do the number line shading thing. I never read it, but we watched it.
This is actually my least.
X equal minus 2.
So go ahead and solve for x and put it on the number line.
1, 2, minus.
Tell me about the 5 minutes. What's in the middle of it? Yeah. How do you get
Okay,
it?
now
Yeah.
it's greater than 10.
Yeah, exactly. Yeah, it's just always think about
So
the
this one-
relationship, like a friendship or a marriage or something. Not just that there's a 5 and an x, but how are they related?
It's going to the right also.
Huh.
See, from here, it's going to the right and leaving a hollow dot. But we start on
well,
2.
no, that one is times, but that one was a
Minus-
whole definition. We had 2x's. Oh, yeah, no, I didn't notice.
But see, when you divide minus 10, you then 5, you give minus 2.
I'm trying to get rid of that whole thing. So you can
The sign gives you the mistake.
that makes sense. So this
Like it
is
said, The sign,
Because I have scratch my neck.
So this one, what?
the sign is like a baby.
I was trying to.
Switch the sign.
Right, yeah, I don't want X in two locations.
Oh.
I'm trying to get rid of the entire day. Whereas right here, I'm not trying to get rid of that
The
entire
only way
five
that
X.
you would ever switch the sign
I just
is
want
if
to get
you're
rid of five.
dividing by a negative
See the
number.
difference?
That's when you would
See, when
change.
there's two X's, you want to entirely get rid of
So
one.
in
Not just get rid of
these,
the eight, but get rid of the whole
So
eight
it's still
X.
gonna be that.
Whereas here, I don't want to get rid of the whole five X, I'd have no more X. I want to just, because he's the only X left.
So now
I
it's
want
gonna
to
be
just get
that
rid of
way,
the five.
right?
When there's only one
Your
X,
X
you
is
want
on
to
this
just get
side.
rid of the number. When there's two X's,
Yeah,
you
but-
want to get rid of the whole thing.
but
below
a
one.
greater number negative, this is smaller.
Yeah. Yeah. We'll just
But,
restart.
no, so let me resolve it this way.
Right, divide
So
it
I'm
with the
here,
same sign, huh?
5x
That's right.
equal, I understand, so I get it.
All right. So
Here is,
we want to get x alone, right? So what are we going to do to get x alone? We're going to divide both sides by 5. Is that good? Is that making sense like that? So let me help on something. I think a good, something I can point out might be helpful. See how in the last one we had x in 2 places? You see, there's a difference between when you have x in 2 places and when you have x in only 1 place, isn't there? When you have x in 2 places, like the last
this one you
one,
can turn it.
I'm not getting rid of just the 8. I'm getting rid of the whole 8x, huh? When you have x in 2 places, you want rid of, that's why I subtracted the whole 8x, not just the 8. I want rid of the whole thing. So it's in 2 places to get rid of the whole thing.
Right.
But that's what.
If it's, whereas number 6 here, it's just in 1 place. I'm not trying to get rid of the whole 5x, am I? I'd have no more x. When x is in just 1 place,
How I make,
you're just getting rid of the number.
You don't,
Everybody see that difference?
you don't.
Just the number, not the x part. So again, if you have x in 2 places, you're getting rid of the whole thing. The number, the x, the whole thing, the lower one.
This is saying this.
But if it's just in 1 place, you divide. Right, good? So now let's go to the number line.
X. Negative 2 is greater than x.
So
So it's bigger than x.
just gonna put it right.
So x is, that says less than negative 2, right? Right? So he's on the narrow side of the symbol. So here's negative. You always put your number in the center. I'll just put negative 2 right in the middle. Okay, now am I going to shade over here on the left side or over here on the right side?
That's right side. Oh,
Where are the smaller numbers? This says x is less.
yeah, you're right.
So how I like to explain it is that arrow is pointing that way, right?
It
Yeah,
is, but
2
the
is
problem,
bigger.
the problem is if the x gets on the other
Yeah.
side, that doesn't
Yeah.
it doesn't work.
So they go-
Yeah, so is everybody good with that? That makes sense? X is less. Lesser things are on the left, aren't they? On that. Carlos.
So the right answer is shading from positive 5 all the way to negative 2, how the line goes that way.
Oh no, the 5 stuff's over.
It's gonna stand it on.
All we're looking at is this now. We're not even thinking about where it came from. We're just saying x, the shading is left of negative 2. So I put an open dot, right, because it's not no solid bar, and I shade left of negative 2. Yeah.
Thank you.
That making sense?
Yeah.
We good? All is
I
well?
understand it now.
Good deal. Does it? Maybe different version. Minus x greater than 0. Okay, so well, what is the name of the game always? It's x wants to be alone, huh? X wants to be alone. X is always saying, I want to be alone. So, well, what is with x right now? What is next to x right now?
Negative.
There's really a negative 1 there, huh? Negative, negative 1, same thing, whichever you prefer, is there. Okay, so whenever there's a number right next to x, how do we get rid of it? Going to divide, huh? I'm going to divide. Does that make sense? I'm not going to add 1 because that number's not subtracted. It's negative 1 times x, isn't it? It's times, and the opposite of times is divide. So I'm going to divide both sides. And you got, whatever you do to one side, you have to do the other. You got to keep the balance, right? So divide both sides by -1. So whenever we divide by the very same sign. Have you noticed that? Whenever we add or subtract, we do the opposite sign. If it's added, we subtract. If it's subtracted, we add. But when we divide by the very same sign. If it's negative, we divide by negative. Why? Because two negatives make a positive x, huh? Now there's a trick here. Does anybody know it? I bet a couple of you already know it. Yeah, when you divide by a negative, the sign has to flip the other way. Are you aware of that? So right here, I've got to flip the sign the other way. So let me write a note on that for you. So right here, I'm putting a -1, here and here. So when you divide by a negative number under the bar, you must flip the symbol. So when you divide by a negative number under the bar, you must flip the symbol the other way. So it's kind of a trick rule. They're trying to trick us there. And then what's the right side? What is 0 over -1? Yeah, 0 on the top of a fraction is always 0. It doesn't matter what's underneath, huh? If I said last night I had 0/3 of the pie. What does that mean? What if I said, no, I'm just kidding, I had 0/10 of the pie? Whatever, it's still 0, huh? It's still no pie. Right? So the 0 on the top means the whole thing's 0. So that had a couple tricks in it. Is that okay? Can we put on the number line thing? So put 0 in the middle. And ask yourself, is the x to the left or the right? What does it say about x? X is less, and so that's left. X is over here, huh? So open circle, shade to the left. Wow. Are we good?
Let's make another like that.
Yeah, we'll do some more with the flipping the symbol thing. Is that okay? So we can divide by negative. Hey, let me ask this. Why do we have to flip the symbol? Why does math make up these difficult rules? And you know what the answer always is? Because it's what's true. I could show you real simply. 4 is greater than 2, right? Okay. That's certainly true. If I divided both sides by -1 and did not flip the symbol, do you see how I would lose the truth? Because what is 4 divided by -1? -4, we good? Because 4 divided by 1 is just 4, and negative is 1. If there were 2 negatives, that'd be positive, huh? But 1 negative is just negative. What about the other side? -2, because again, 2 divided by 1 is 2, and 1 negative is negative. Now, is this true? Is this a true statement? Let's go to the number line. Here's 0. Here's -2. Here's -1. Here, let me. I'm a little sloppy there. I need a little better number line. So here's 0, -1, -2, -3. So here's -4. Here's -2. Which one is actually further to the right?
-2.
This one. This is the bigger number, huh? -2 is bigger. Like if you think financially, being $2 in debt or $4 in debt. I got 5 kids. I just live in debt. $2 in debt, $4 in debt. So which one's a better financial situation?
-2.
This is higher. But see how this is saying the wrong thing? It's saying the -4 is the greater one. That's not true. So I'm just showing to you why math turns the symbol, because that's what's true. When you divide by a negative, you have to flip the symbol the other way, or it's not true anymore. Okay. So there we go. Let's try that one. Feel free to, when you have decimals, definitely use a calculator. Is that number 8?
Yeah.
Oh.
Oh my God, I don't like decimals.
Yeah, just use your calculator when there's decimals. Definitely use your calculator when there's decimals.
The number by negative.
Okay, so x is saying I want to be alone, like always, and so I divide, because that's multiplied, by negative 0.7. And then what if you do one side, do the other? And so notice I'm dividing by negative, huh? So divide by negative. So when you divide by a negative, what do you have to do? Flip the symbol the other way. So these cancel. X is now less than. Divide these on your calculator. Two negatives?
Positive.
Yeah, so I would just do that, by hand. I would just think, okay, two negatives positive, and then I would just go 4.2 divided by 0.7, my calculator 6. I mean, you can put in the signs if you want, but what I found is easier is just to do the straight numbers on my calculator and just do the signs with my head. Two negatives, positive. Because that's pretty easy, right? Two negatives is positive, and then just divide the numbers 6. You good there? Is that making sense? And then we can go to the number line, put the 6 in the middle, and decide if that x is on the left side or the right side. Yeah, lesser numbers are on the left. Huh? X is less. Open dot, because there's no solid bar. Shade to the left. It's getting easier? I think it's better than that last section. Oh, crazy word problems. Questions there, okay? The rest. Okay, let's try that one. So y wants to be alone. So how can we get rid of that 3/8?
We can go keep man.
Yeah, call the hitman. The shooter, Manuel calls him, right?
Shooter. A cancel. We got 3y. This is time.
Yeah. Remember what we always do when there's fractions? What do we always do when there's a fraction? We call the hitman. We multiply by the denominator. You know what I mean? So I'm going to go 8 on both sides. And it takes it out right there, huh? Is that making sense? Isn't that what we always do when there's denominators? Is we just multiply by that denominator, all the terms. By that, I call it the hitman because it takes out the denominator, right? Is that good? Is that making sense? So we multiply both sides by 8. It takes out that denominator right there. And we then get minus 3y 72. Everybody see how we got rid of that? No more fractions. How we got rid of that 8? Is that good? Can I help in any way with that? Is that making sense? Yeah, comment?
I was just curious. Couldn't you just multiply both sides by negative 8/3?
Totally. You're doing a really good thing. Yeah, you guys are totally right. That's the other way. Yeah, that'll do it in one step. It's a little quicker. That's great. It's totally great. Yeah. If you do that though, you're multiplying by a negative. You got to flip the symbol. Yeah. So I'm going to do that now. So now my next step, y's got to be alone. So I have one more step to do. I've got to divide by negative 3. So there it is. I'm dividing by negative. So really, it's actually multiply or divide by negative that you have to flip the symbol. I just didn't want to give too many details all at once. Yeah, Carlos.
Anytime there's a negative on either side, you can flip the sign.
No. Yeah, good. I'm glad you brought that up. It's not just if there's a negative there. It's not. It's if I divide by a negative, or I multiply. So in other words, it's the action I take. It's a verb, not a noun. It's what I do, not what is there. So it's the action I take. It's what I put under the bar. So Carlos's question is a good one. That's the tricky part, is it's what you divide by, right? If you divide by a negative, that's when you got to flip the symbol. So right there, I'm going to flip the symbol the other way, huh? On that. Is that good? So then what do we have? This is y, and this is what, minus 24? And then we can go to the number line. Put minus 24 right in the middle. Is the y, is the shading, on the right side or the left side?
Right.
Y is greater. Greater stuff is always to the right, huh? Y is over here. So the shading is that way. Open dot or solid dot? Yes, solid, because we have a solid bar. Solid bar, solid dot.
Okay. We flip the number. I mean, we flip the symbol,
Right.
both symbols, but we keep it negative because it's only one negative divided.
Right, right. Yeah, so yeah, positive, negative, only one negative, the answer is negative. Yeah, so it's not whether the answer ends up negative or positive that makes us flip a symbol. It's the fact that I put a negative under the bar. If you put a negative under the bar, regardless of what the answer comes out, if you put a negative under the bar, you got to flip the symbol.
Flip the symbol.
Yeah. Is that good?
Negative.
All right. Okay, so number 11, try that one. I think it'll help you to put the wall in there. Just keep your vision clear, left side, right side.
It makes more sense.
Okay, so we have x on opposite sides. What do we always do with x on opposite sides? Is we get rid of the lower one. So subtract 3x from both sides. And then we come to there. Good so far? And now x is saying I want to be alone, so let's get rid of that 13, right? So let's subtract 13 from both. And we've got, what is that, minus 18? Good to there. And now, last step is always division. We're going to divide by the 6. And am I going to flip the symbol? No, because I'm putting under the bar a positive number, not a negative. So it doesn't matter that there's a negative there. It's not what's there, it's what I put under the bar. So if I put under the bar positive, no flipping the symbol. If I put under the bar negative, then I got to flip the symbol, huh? So no flipping, just keep it as it is. Okay, let's bring it on down. Now, what is 18 divided by 6 is 3. 1 negative is just negative, huh? If that was 2 negatives, it'd become positive. Again, no flipping the symbol, though. It's not about what it becomes, it's about what I put under the bar. And I just put positive, so no flipping. Now, can we go to the number? Here's the trick I really wanted to show. All that's mostly normal stuff, nothing too new there. But here's the new part. So dial in with me if the rest was not really new. But catch this. Make sure you don't miss this. This is what fools a lot of people, is which way does the x go? Now, when you read an inequality statement, see, the trick on this one is x is over here on the right side. But it doesn't matter, right side, left side, whatever, if you'll always read it starting with the x. So in other words, you don't just read left to right. I mean, you could. There's nothing wrong with it. But students tend to get confused. So let me give you advice. Always read starting wherever x is. So what is it? X is what? Greater, bigger, larger, because he's on the wide side. So x is larger. Larger. So which side am I going to put x on? Where's the larger stuff? Right. To the right. And we have a open, don't we? Yeah. Open dot. Does that make sense? The x is greater. See, a lot of people read it and they think that they can just start over here in the left and go, oh, less, I'm going to go left, but that's not correct. Well, I mean, negative 3 is the lesser one, is what that's saying, which means x is the bigger one. Yeah. And you're always shading the x. So the x is to the right.
You always write x before writing where the value going?
No, what I'm saying is when you read it, how you read it, start with x. When you say to yourself, what is this saying? Start with x.
So what I can do is just switch it put it like in a box.
You could.
X.
Good. Yeah, what Manuel's saying is true also. You could always take the whole thing and just switch it all around, symbol and all. So that, like this, if you enjoy that more. That's saying the same thing, isn't it? See, because x is still greater, x is greater. They're saying the same thing, aren't they? So if that helps you, if you prefer to have x on the left, just flip it.
And like everything I do, always try to put X first, and then the symbol, and whatever the.
You don't have to. I mean, it's okay to leave it like this. But if it helps you read it, then go ahead. Yeah.
Thank you.
That makes sense. So watch out. That's exactly what they're trying to trick you on there, is what to do when x ends up on the right. You can just flip the whole thing. Okay, so try that one. Hopefully you're getting more and more comfortable. I think you are. These. I think you're all getting the hang of these things. So, all right, so we distribute the 3. And so we get, what's that, 6 minus 3x? Like that. Okay. And so now we have x's on opposite sides. What do we always do when we have x's on opposite sides? Yeah. Do the opposite. It really doesn't, this is where I'm going to say it really doesn't matter which one. You could get rid of this one, that'd be plus 3x, but then you have to do the same thing to both sides. Or you can get rid of that one, and that'd be plus 5x both sides. It doesn't matter. Just, what did most of you do? Plus 5, because that is technically the lower one. It doesn't matter. But I'll do what most of you did. It'll work either way, though. You just have to get rid of one of them. It doesn't matter which one. So both sides gonzo there. And that's plus 2x. Is that good? There. And then wherever x ends up, that's the side we have to get him alone on, huh? He's over there on the right side, and he's hollering out. When he's always hollering out, we'll be alone over here. So that means you got to get rid of the 6, and then get rid of the 2. Start with the 6 first, because that's furthest away. Right, peeling an onion, get rid of the thing furthest away. So you get rid of that by subtract 6 from both. That'll be what? Negative 4. And then last step to get x alone is always divide. And then these cancel. Do I need to turn the symbol? No, because I put a positive number under the bar, huh? Not a negative. So no turn symbol. Negative 4 over 2. It's negative 2. Right, 4 divided by 2 is 2, and it's negative. Okay, now if that bugs you, having the x on the right side, you could always flip the whole thing around. Flip it all. You can always do that. Because that's saying the same truth, isn't it? Right? Because see, x is on the narrow side, x is on the narrow side, x is less. Same truth. Either way, if that makes you more comfortable, you can always turn it all around. You don't have to. And so what's our answer then? I got to go to the number line here. And number line, going to put my negative 2. Which side am I going to shade? The left side of the negative 2 or the right side? The left, because less. X is on the left. Open dot, shade to the left. How are we doing? Is getting more comfortable? Algebra's doable. It's just a lot of practice. It's a language, just keep practicing daily. All right, I'll move ahead. No questions? All right, let's try that one. Here's the wall, if that helps you look at it. Try that. Anymore. All right, so, so we distribute. So we'll get 30x minus 6. 30x minus 6 less than or equal to, and distribute 28x minus 28. Good so far? And now we have x's opposite sides. You know what we do? We get rid of one of them, usually the lower one. So minus 28x from both sides. So we get 2x minus 6 minus 28. Okay, now x is the same what he's always said, I won't be alone. So what do we do to get x alone? Add the 6, right? We all good with that? And so then we have, bring this down, 2x, what's this, minus 22. And last step, divide by 2. X less than or equal to minus 11. Then we go to the number line, put minus 11 in the center, solid dot, huh? Because we have a solid bar. And which side is x on? The left, because x is less. It's on the left, so the shading goes to the left. We good? Questions on that one? Okay, so that one's a little harder. There's the wall.
Just a little bit.
This will dive into the word problems. Right, so this minus 4 is going to distribute in, the parentheses are going to drop, and then this minus sign is also going to distribute in, huh? That's anything up against the parenthesis wall. The walls come down, the water goes in.
No, keep pressing.
All right, let's take a look. So when this minus 4, so I really would encourage you to do what I'm doing as far as a little arrow there, so that you'll know the minus 4 goes boom, and the minus 4 goes boom. So minus 4 times 1? Minus 4. And minus 4 times minus x? Plus. Two minuses make plus there. Is that good? So they both have a negative, right? A negative 4 and a negative x, 2 negatives. So 2 negatives multiply always make positive, huh? Plus the next x. And now same thing here, negative 4 and plus 2x, right? Because again, the 2 negatives make positive. We good to there?
The
And
negative 4 and the plus 4 cancel each other out.
good, totally. Yeah, they're just gone, huh?
Yeah.
Good job. That's right. And what about on the other side? Yeah, 4x plus x. Yeah, it makes 5x, huh? So we all good to there? Okay, so now at this point, what are we going to do? What do you do when you have x's on opposite sides? You get rid of one of them. It doesn't really matter which one. I usually get rid of the lower one, but you don't have to. So if you do what I normally do, you would subtract 2x, huh?
Right.
That might throw you off. Let me show what that looks like, because I know this kind of gets people sometimes. Let me show. So I'll do it that way. But really, if you subtracted 5x, that'd be a little quicker. But anyway, it's fine. This is what I normally do, so I'll just do it that way. So what becomes of this, though? That'd be minus 4 plus 3x. Everybody good so far? 5 minus 2 there. 5x minus 2x. And what happens on the other side? Yeah, you want to actually write 0. Yeah, don't bless you. Don't just leave a blank or something. You want to actually write 0. That's where people get kind of messed up. At least what I've seen over the years is when these cancel, they'll kind of just like write nothing, and pretty soon they don't write the symbol, and they get lost. Just go ahead and put 0. Keep the symbol. It's all good. Just keep right on moving. X is still saying I want to be alone. So what do we do to get x alone? Add that 4, huh? Because we got to get rid of whatever's with x. And we'll do to one side, got to do the other. These cancel. 3x greater than 4. And last step, always divide. X greater than 4/3. Now you could have got that some other ways. And you might have had it written a different way. In the end, it's going to be open dot with 4/3. It's okay to have a fraction. It's just 1 1/3, just a number. And the shading is to the what? Right or the left? Because x is greater. Greater stuff is to the right. Greater numbers are always to the right. Does that make sense? If you ended up getting it like this, that's the same answer, isn't it? some people might have got it looking like that. That's the same thing. Good on that one. You ready for the word problems? 9 o'clock at night, you feeling like word problems? That's what I always feel like at 9 o'clock at night. All right, so there we go. There's number 16. Can you turn that into a greater than, less than kind of problem and solve it?
Big more. It's greater.
So 3 more. What do we always do with 3 more? 3 added, huh? Twice a number. 2x is greater. Negative 11. Good to there? And then we just solve for x. This is an easy one after all that other stuff, huh? X is 10, I won't be alone. So what do we do to get x alone?
You see the number 2.7.
What's that going to be on the other side? Minus 14. Right, if you lose $11 and lose $3, you lost 14. Last step as always. Divide.
X is right there.
Do I need to flip a symbol?
No.
I got a negative 7 though. Yeah, good. It can't shake you. I'm glad. It's not what comes out. It's what you put under the bar. I put a, bless you, positive under the bar, so I don't turn the symbol, huh? So there we go. I don't know if they want shading, but you could do it. Let's move on to number 17. Okay, so number 17. It says, with that picture, it says perimeter no greater than 70. Perimeter no greater than 7. Let me give you a second rather than me just diving in. So perimeter is 4 sides added, huh? There's that bell. So x and 25 and x and 25. Good. The 4 sides added. So x and 25 and 25. That's all perimeter. So that's 2x plus 50, right? That's perimeter. No greater. No greater. What does that mean? If something's not greater, if it's not greater, if it's not bigger, if it's not larger, then it's less or equal. Because if it's not greater, it could be equal or it could be less. Does that make sense? Right? If you're not greater, if I said, hey, my friend, I'm 51 and his age is not greater, what does that mean? He could be my age, 51 or lower, right? It means less than or equal. Less than or equal to 70. So perimeter, not greater, less than or equal to 70. So there's our equation. Let's solve it. 2x plus 50, less than or equal to 70, subtract 50. 2x less than or equal to 20. Last step is always divide. So x less than or equal to 10. X less than or equal to 10. Is that good? Questions on that one?